My organization is called the San Diego Regional Data Library. We do pro bono data services for nonprofits, journalists, and governments. We work with a lot of volunteers, and it's a wide variety of projects, sometimes working with crime, street sweeping. We do projects involving weather and water quality. This is a project we've been working on for the last year for homelessness. And because homelessness is a major issue in the United States, also within San Diego in particular, which is the fourth largest number of homelessness in our continuum of care, which we'll talk about what those organizations are a bit, about 500,000 per year. One of the challenges we have with data, and also one of the opportunities, is that homelessness involves people, and data is an easy way to extract from people or abstract from people. We'd like to try to keep that humanized. One of our last meetings, we invited an artist who does portraits of homeless folks, Neil Shigley, to talk with us. And I'm not sure which of us learned more from the other, but his work, his experience, and our experiences in working with a variety of groups, we're trying to find ways to use these data to tell a better story, to remove some of the myths about homelessness, and have people a better understanding of the folks who are actually afflicted by it. There's about 500,000 homeless in the United States right now. It's been going down slightly. Most of those folks are sheltered. We have a substantial shelter system, but there's around a third of them are not, about 200,000. Fortunately, most children and families do find shelter, but the folks you're likely to meet outside, about 70% of those are men, are living out, sleeping rough, as they say in Britain, living outside. Now, that's not as much of a problem in San Diego. We have a much larger portion of homeless folks that are outside because the weather's better. We'll show you that number in a minute. Here it is. So we've got about 3,600 folks that are unsheltered. They're persistently living outside. Sometimes they'll visit shelters, but any one time there's about 3,600 outside. About 8,000 total. These numbers come from an annual point-in-time count, which is a large effort. Has anybody done the point-in-time counts? You go and volunteered for them? You can go out every January. Your local COC, the Continuum of Care organization, will organize a count in which people go out on one night in January and actually count folks who are sleeping on the streets. This is really important for allocating money. In fact, we've got an issue right now in California. Governor Newsom just signed an emergency bill to allocate funds, but the federal government hasn't finished with the point-in-time count, so they don't know how to allocate the money. The top organization in the national chain of organizations that work on homeless issues is Housing and Urban Development. HUD organizes Continuum of Care, which are regions, about 600 regions around the country, that HUD allocates money to one organization that's the manager for that. And then that organization collaborates and works with all the other organizations within that region. So a good part of LA County is one Continuum of Care, San Diego County is another, and the rest of the country with smaller counties, they tend to be multiple counties, multiple cities all working together. Those other organizations can be nonprofits, they can be shelters, churches, community groups. The COC manager will work with all of them and help to distribute money within those groups. Those are also the data sources you're going to see for homelessness. HUD is the focal point. If you go to the HUD websites, we'll show you a few of those here, you'll find an incredible array of data, just about everything you want. Everything you want's there. It's not always easy to find. In fact, one of the things I'll give you is links to our data collections. There's a bunch of files that I found, can't find again. We have copies of them, but they're great for analysis. But the other place you might find data is your local COC. The Regional Task Force on the Homeless in San Diego, or the Los Angeles County Housing Authority here. They will often publish data sets on their own, sometimes at much more detail than the federal government does. You'll also find custom surveys. You can find extracts from homeless management information systems and local surveys and counts. Outside of the federal government's stuff, everything else, you pretty much have to talk to people to get. It's very rare to find the more detailed information explicitly on the web. One of the processes we had to do to get good information involved a year-long effort to locate, extract, download, process, and clean up and digitize a very large stack of PDF files. We'll show you that project in a bit. HUD manages those COC, the Continuum of Care. That's about $2.3 billion a year. It's a very large project. In San Diego, it's about $600 million a year that goes into homeless services. Some of those sites, HUDuser.gov is the main site for storing homelessness data. That includes special tabulations of the American Community Survey, which will tell you about 50% or the median housing costs around the country. You'll get crosswalks. There's some really interesting files here telling you what the United States Postal Service vacancy rates are when a house doesn't pick up its mail. The Postal Service records that as vacant. HUD has those files. You can find out what vacancy rates are around the country. Also, lots of crosswalks. If you want to take zip codes and map demographic data into tracts, zip codes and tracts are, well, first of all, you shouldn't do that because zip codes are terrible. But if you have to do that, you need crosswalk files to link those two geographies together. And those are at huduser.gov. HUDexchange.info is another site that HUD uses to collaborate with the COCs, the Continuum of Care organizations, when they report their point in time counts. They go out every year in January, they count homeless folks who are sleeping outdoors. The shelters report how many people are in beds. They send that to HUD. HUD puts that at HUDexchange.info. Now, you can't get to those files because they're private. A lot of them actually have people's names in them. But there are some files here that you can download. Again, they're kind of hard to find. I've got other links to them, which I'll show you in a bit. The most important stuff at HUD Exchange is the point-in-time count methodologies. If you want to work with point-in-time count data, it's really important to know exactly what's going on in the data. Stuff changes from year to year, and this site will tell you how the methodology works. Our regional group, the Regional Task Force for the Homeless, runs that point-in-time count. And they publish some data and not others. We've got a kind of a spotty collection of data. I've been collecting that. So again, if you're interested in analyzing it, my site's probably the first stop. But if you talk to them, you can often get specific files for particular years. The data management's a little spotty, but there's often some really amazing information that's available if you talk to folks. The big one is a point-in-time count. We've talked about this a bit. This is what the data looks like for 2010. I happen to have a friend who digitized the data in 2010. He was hired to do this. He's a GIS guy. So I got that file. It's really hard to get the other files. They get point data. The way they do the counts is they send out people all over the county. In San Diego County, all 625 tracts have at least 2 people that go out. They have a paper map, and when they find someone sleeping out, they mark it on the map. Those maps then get tabulated and reported back to HUD with a number of homeless sleepers per tract. But those maps get filed and they have position information on them, which sometimes gets geocoded. You can see we've got downtown area down the bottom here is where most of the homeless folks are staying. Ocean Beach, if anybody been to Ocean Beach, it's kind of an interesting place. Yeah, they've got a homeless issue just south of the pier, around the pier area, and a couple other parts of town as well. But it's really centered around downtown. And because there's so much homelessness downtown, the San Diego Downtown Partnership has been, which is originally started as a group of churches and other business organizations, has received funding for the last 7 years to do their own count of homeless sleepers downtown for about 350 blocks. This is an amazing data set. It's just like the point-in-time counts, except it's 7 years on a monthly basis. We can do all sorts of incredible stuff with this. Unfortunately, it's all in PDF files. They will go out the same way that the point-in-time count works. You send out some people with a map, they mark where the sleepers are, and then they add up the number of counts on that map and write that down, and you can get that data. What they don't do is digitize the maps. It's a lot of work. When I found this, I realized that we can use this to look at how homeless clusters according to changes in land use. We can look for what happens when you put in a new bathroom or a new park. What happens when you put in the tent that they put down in East Village in 2017? What happened during the hepatitis outbreak? These are all things that we can look at geographically if we have this data geocoded, but we've got 350 paper maps and no budget. So how do we do that? We'll talk a lot about that. Another local organization for Los Angeles is the Los Angeles Homeless Housing Authority. They have some really fascinating data, which includes both the point-in-time counts and surveys of individuals for how long they've been on the streets, drug use, sexual assaults, alcohol use, everything else you might want to know about these folks has gone into probably 30,000 points, 30,000 records. Unfortunately, that was difficult to get to. We managed to get it through an organization called the Economic Roundtable. And again, these files are hard to find. I've saved them so you can analyze them. This is a view of how homelessness and land use are related. The regions, the ones that are colored, you can see the fade or the color scale down below. It's a relative scale from least to worst. Yellow is Skid Row. There's an actual Skid Row. It's the yellow spot. And then the dots show you different land use. It's fairly typical that homeless folks cluster in places where they're not going to be bothered by a lot of people. So they tend to stay out of the way, unsurprising, and that includes a lot of light industrial. There are a substantial amount of homelessness in multifamily, but it tends to be mostly in the light industrial, heavy industrial, and commercial sectors. The organization that liberated that data was the Economic Roundtable. Really interesting group. These folks are bulldogs. They often get in trouble. They've had a couple lawsuits over use of the data because they managed to get enough data to be able to do a predictive model for homelessness. That was, the county didn't like that one so much for a variety of reasons, but we do appreciate the amount of effort that goes into to getting data out to be usable. They've done data dives with DataKind. You can find their site at economicrt.org. Again, though, the files that I was able to get from them are a little difficult to find right now, so I'll give you links to those. And those are all on the San Diego Regional Data Library's data repository in our homelessness collection. The data.sandiegodata.org. If you go to our site, you'll see both the Los Angeles data sets, a bunch of stuff from San Diego data. Across the whole space here, there's quite a lot of useful information. This is one that we send researchers to quite a bit because some of these files are really tough to find. And here's this one got in the wrong spot. If you go to PyData, our website /PyData, you'll get links to this presentation and links to all the other sites that include this data. Let's go back to... Now, I mentioned that from the San Diego Downtown Partnership, we got a stack of PDF files of handwritten maps. Incredible data set, not digitized. So we started working on digitizing it. One of the first groups I talked to was the students of Corianne Burgess at Kearney High. We've done a lot of data projects with these folks. She's awesome. She's really dedicated to social issues. She's really dedicated to data and computer science. She's got a really amazing group of students. And so we said, hey, let's do a data project. Let's get you this data for one of the neighborhoods, Gaslamp. Anybody been to Gaslamp, San Diego? Familiar with that? Yeah, it's a party town, very long and vertical. It has a substantial homeless population, but clustered in certain areas. It's small as a neighborhood, so it made a good neighborhood to us to work with on this data set. Unfortunately, though, the way that you geo-reference paper maps, when you take a paper map and you have to figure out how does the pixels on the map relate to latitude and longitude, is complicated and difficult. The tools for it, both in QGIS, which is an open source tool that I use mostly, and ArcMap, which they had access to, are tough to use and really hard to train on. So we were looking for a different way of doing it, and Corianne came up with a really simple one that was really quite brilliant. You can use ArcMap tools to create web forms, the kind of form that you'd send with somebody if they're going to go out in the field and record where graffiti is or look for streetlights that are burned out. You make a little web form, they can poke on the map where something is and record that as a data point, and then you can extract that data later. Well, they just did a web form for downtown, and the students put the web form on one part of their screen and they put the map on the other part of their screen, and they just eyeballed it. I was a little skeptical. Turned out to work really, really, really well. Much more accurate than I expected, and we got some great results out of it. This is a student analysis of homeless concentrations over time. They've done heat maps for different periods. And what they did by looking at this was they figured out that there's one particular cluster, you can see this in the October 1 to January 1, 2018, that is related to closing of a particular theater, the Gaslamp 15 theater closed down. It has awnings, and now it has nobody in it. So it became a magnet for homeless folks trying to stay out of the weather. That was a really powerful insight that the students got. I was quite surprised. They even went on to Google Street View to survey the building and figure out that's what was going on. They also looked at comparing rent to homeless counts. And this was precisely one of the reasons we created this data set, was to give students a way to engage in a social issue, do it from a data perspective, and in a way that even high school students can work with. Now, once we finished that, we needed to go digitize the rest of the data, and I did want to do something a little more accurate than eyeballing maps. So we had to do a little more innovation because, like I said, the standard way of georeferencing a map just takes too long. It was very much more difficult than we needed. So what it did was wrote some software, in Python of course, to extract the images from all the PDFs. Turns out it's a little trickier than you'd think. The way that PDFs store images is kind of crazy. There's a lot of formats that are based on facts from 25, 30 years ago. So you have to work around that. But once you get the images out, we used an optical character recognition library to figure out what map is what. They have the name of the map on them. We can find that, so Cortez or Gaslamp. And then the programs would organize all those maps into jobs, create a ticket on GitHub that when you click through that ticket, you would get an annotation tool. This is an annotation tool called VIA from the Visual Geometry group at Oxford. It's a really awesome tool. It's a single file HTML file. You just download that one HTML file, stick it whatever, fire up the Python simple HTTP server. You can run this tool. And it's for annotating images for doing vision processing. If you've done any computer vision work, you spend an awful lot of your time drawing boxes around cats or whatever you're trying to recognize. If you want to find people or dogs in a diagram, you have to draw, say, here's a cat, and you have to do that 1,000 times. So we used that tool to do 2 annotations on these images. The first one, this is a job that was constructed by the code, so that when the student or the volunteer clicked into it, they only had to do this job. You can see where it says 2, you'll see a little yellow box there. There's actually 4 of those yellow boxes. Those are annotations of specific intersections. You draw the box around the intersection and then in a pull-down list say which intersection it is. We know where that intersection is. We have the latitude and longitude for it. And with 3 of those points, the 4th one's a bonus, with 3 of those points you can create an affine transformation matrix that lets you go from pixels to latitude and longitude. That gives us the second job. This is what those final regions look like. The second job is to do exactly the same thing, but to digitize the positions of the homeless sleepers, the marks on the map, so that you'll see the number 2 over number 1. You draw a circle around that, type in a 1. Real simple task most of the time. These take about 15 minutes to an hour or 2, depending on how much data there is. And there's a couple other data they'd annotate. We could easily break this up, get in dozens of volunteers, and do this over the course of a couple weeks. We got most of it done in a couple weeks. The scragglers' jobs finished off after about 2 months. That gave us a really fantastic data set. The cleanup involved geo-merging to census blocks, because we got latitude and longitude. We aggregate that to census blocks. And then we can do some missing data imputation because 3 of our files didn't work. If you go to the PyData LA link that I mentioned earlier at the San Diego Regional Data Library's website, you'll find a Google Colab notebook that walks you through generating this particular map. It's a good exercise. I actually use it a lot for training people in GeoPandas, which is one of the astoundingly awesome tools in the Python toolset. Here you can see what that data set looks like at homelessness in San Diego. This is the total count. The blue line is the official count. It's the numbers that they took from adding up all the marks on all the maps. It's a longer data. We didn't get images for everything before 2014, but we did get the data number or the number of sleepers. You can see the big rise in 2016 through 2017. You can see the 2 spots that are missing, which we imputed. Probabilistically, we took the number of folks that were sleeping in each region prior to outside the missing regions, and we just ratiometrically added them back in on a block by block basis. So it's basically, if you try to do correlations across those months, you'll get the same correlation as you got the previous month, but the graphs work out just great. You'll also notice at the very end, there's a divergence in the 2 lines. It's not an error. The difference there is in 2017, HUD came up with new multipliers for what you multiply a count when people are sleeping in a car or a tent. It's like 1.17 and 1.46. We didn't want to put those multipliers in the data, so we left them off, but the official numbers have them, so that's why the diversion's there. In San Diego, the homelessness issue diverges by neighborhood as well. The largest neighborhood is the one down in the southeast corner. You can see the hot spot down there in yellow and green. That's East Village. East Village is less industrial. Well, it's more industrialized. It's got less entertainment, more warehouses, more large laundromats. And so the homeless folks tend to cluster there because they try to stay out of the way of people. You'll see a little bit more in the north section. That U-shaped block is Horton Plaza, which was previously a mall and is now being redeveloped, I think, into a business park. And there's a couple other spots here that I'm not precisely sure exactly what they are because I didn't, put the underlying map. But it's mostly East Village. East Village is also where the largest rise and fall has come over the years. That was one of the questions we're trying to figure out is what's the reason for this? Unfortunately, because we only have downtown, we don't know precisely what happens to where homeless stay in response to policing. It's quite possible that the rise and fall was because the police were more aggressive policing outside downtown, so homeless folks moved into East Village, and then they got more aggressive in East Village and moved them back out. We're still looking for data on police stops to try to figure out exactly what that is. But the one interesting thing that was really interesting was to see if there's any connections between that rise and fall with the hepatitis outbreak. We had a major hepatitis outbreak, but I unfortunately forgot exactly when it was. Fortunately, you can go to Google and ask them. This is Google search trends for San Diego hepatitis. We just looked for the spot where there was the most news articles on it. That turns out to be September of 2017. Slightly around that time, one of the responses was to put a homeless tent. It's one of those big tents that if you had a really big wedding outdoors, you get the big white tent. They had one of those that basically covers a whole parking lot. That went in late 2017. But as you can see, there doesn't appear to be any particular connection between these things. This is one of the things that I've had to get used to over time is reporting false results. If you've been following the replication crisis in just about every field of science, you know that there's a publication bias. So I try to get myself worked up when I say, hey, we found nothing. In this case, we didn't find anything. We looked at about 6 other items. You'll see these in the Google Colab notebook. We've got some really interesting data sets in San Diego. On this side on the left, you've got the homeless data set, and the other side is pedestrian traffic. We have pedestrian traffic data by hour, actually by 15-minute intervals, for years. And we have that because we have smart street lamps, which a lot of folks are not quite as excited about because they see them as Big Brother. I'm a little on the fence on this one. If you go down, we got about 4,400 smart street lamps that have 4 cameras and a big 1 gigabyte Atom processor on them. They are watching you all the time. They claim they don't do face recognition, but they do object recognition, and of the objects they recognize, of course, are cars and people. So they've got virtual lines crossing sidewalks, and those are called walkways. It's for some reason you walk across the walkway, not in the walkway. But you'll get reports of how many people are crossing those walkways each time. It's a little weird data. The most frequent speed across these walkways is 5 meters a second. If you kind of work out what 5 meters a second looks like, it's pretty much running. So either everybody in San Diego is running all the time or they're on scooters or the data's wrong. We think the data's kind of wrong, but we took the counts and break them out by time. We'll just assume those are right. They actually look pretty much what you'd expect. The yellow in the center there, that's basically the hot spot of the gas lamp district. This is a Saturday evening, so we're looking at party traffic and looking for correlations. Do homeless try to avoid places that have high pedestrian populations? Yeah, we didn't find anything. partly because you can see there's a lot of pedestrian traffic happening in East Village. That's probably not party traffic. It's probably lots of other folks going to and from apartments. But regardless, we didn't find strong correlations with that one either. We looked at crime, a wide variety of crime. We also, in San Diego, have some really awesome crime data sets that go back for several years. In this one, the gross correlations don't work out very well. You can see the gas lamp in Horton Plaza. We're not entirely sure why Horton Plaza is so high. It might be that these are alcohol violations, so it might be folks drinking in the park to the north of it and they're getting nicked by the cops. But there is, you can see in East Village, a hotspot for crime. This probably is, there's a couple bars down there. I think Mission, is it Mission Brewery down there? Is that what? Yeah, so it might be that. It might actually be, the ballpark is pretty close to where that is just to the west of it. So that might be part of the problem. We're not real sure either. Regardless, we didn't find a strong correlation. In fact, there's not a lot of correlation there at all. We get a little bit of correlation between the lunch traffic on Wednesday nights and Wednesday day, but you can see the yellow, the sleepers, 0.16, not a lot there. Which is actually kind of good. I mean, one of the myths that a lot of folks who work in homelessness want to dispel is that homelessness are necessarily a high crime population. In San Diego, almost all of our crime, it's a remarkably safe city, one of the safest in the country. Most of our crime comes from car thefts and drunken assaults. So if you're downtown or you live in my town, Pacific Beach, that's where you're most likely to face violent crime, and it's always going to be somebody who's been recently at a bar. Homeless folks aren't spending a lot of time in bars, so they're not really that much of a problem on this. The crime crime's been is a fascinating data set, and particularly as it connects to homelessness, but it's also got some other interesting features to it, one of which we used to test doing some analysis on some temporal analysis, particularly using fast Fourier transforms. Are you familiar with FFTs? Basically. Yeah, so an FFT is a way of breaking a signal down into its constituent frequencies. If you could take a signal and add up a bunch of sine waves, you can create any signal you want by adding up those sine waves. The fast Fourier transform allows you to break it up that way. What it does when you're doing a signal where you've got a data set, a time series, is you're looking for periodicities of frequent events. So for our temporal analysis of crime, you should expect quite a lot of that. These are what I call rhythm maps. The horizontal axis is the day of the week. Sorry, I use numbers and not letters. The vertical axis is hour of the day, and you can see a lot of patterns. I love this set because it's got more patterns than any data set you'll ever work with. You can see the 5 o'clock lull, the vertical yellow lines across most of these things. You can see in burglary the Friday night commercial crime and the midday weekday burglaries. You can see sex crimes mostly happen in the middle of the week. I've asked lots and lots of crime analysts why that is. Nobody knows. So we should be able to find some patterns if we look at these data sets. This is temporal analysis. Another rhythm map. The week of the year is on the bottom, hour of the day, and you can see that most of our crimes, alcohol crimes, happening in the afternoons in the middle of the summer. That strong line down the middle of the summer, that's the 4th of July weekend, and that line is entirely there because of Pacific Beach. Seriously, when we outlawed alcohol on Pacific Beach, that line disappears. It's a really amazing pattern. So let's go see if we can reorganize some of those things. In this heat map, there's 1 hour per cell. There's 2 weeks, 2 times 168 cells per row. And when you organize it by 2 weeks, you can see it neatly lays out into daily and weekly patterns. The stronger red lines going vertically are the weekends. And then the yellow stripes are 5 o'clock periods. So you can see there's a very strong weekly and daily pattern here. So let's see if that works out in our FFT. It does. Fast Fourier transforms, any kind of signal analysis like that, is kind of expecting that you have an infinitely long signal, and you don't. So you get all sorts of weird noise because you've got cutoff on the end. You're supposed to throw in a Hamming window on this, and I don't think I did it on this one. It didn't really matter all that much. You still get all the crap in there. But what you do see, you see a really strong line at the top. That's 24 hours. That is the amplitude of the signal that oscillates at 24 hours. We have a daily period. You also see a really strong signal over there. That's 168 hours. That's our weekly period. So analysis checks out. It actually works. What happens when we do, excuse me, homelessness? Yeah, we get nothing. Strongest period is 42 hours. I can think of no good reason why there's a 42-month cycle in our data. Just none at all. 3 and 4 months, you might come up with a good explanation for, but probably not. This analysis should have showed us a 12-month period if it existed, but as it turns out, you get used to this when you analyze data in San Diego. There's no seasons, so we don't have 12-month cycles either. We tend to have cycles that correspond with holidays. That's why the 4th of July cycle is there in the crime data set. But the homeless don't they don't come and go for Christmas and Thanksgiving, so we don't get any of those patterns. There's a lot you can do with this. Unfortunately, again, like I said, I like reporting negative results. We're finding that homelessness has the only real strong pattern there is that big hump that comes out at 60 months, and we are still working on figuring out why that is. If this sort of stuff excites you, we would love to have some help. This is an open source project. And you are welcome to join us. The one that we're working on slowly, really excited about, is doing machine image recognition to complete the missing fields, the 3 missing months, and all the months that have come after that. We got about a year of data that we need to go through the digitization process with. But we have about 20,000 annotations of digits. Some of them are here. Did anybody done the digit recognition, machine learning example? Are you familiar with that? Yeah, okay. Do those digits look like good ones? No, they're a pain. We've got all sorts of crud in there. The example data set you use for object recognition has nice, clean, handwritten digits. Ours have the residue of circles and streets on them. So we're looking for some folks up to a challenge to try to get rid of that and turn those numbers back into geographic positions that we can use to complete out the data set. We've also got a lot of questions that are open. We have a site, one of the subsites of the data library is called Insights. And it's a simple question and answer site. We collect questions from the public. Often I have to go around and beat on bushes to get questions. In this case, we went and talked to a whole bunch of folks, some of which were actually at Economic Roundtable, experts in homelessness, folks who are working at SDSU, folks who are working in the city of San Diego, and asking them, what do you want to know about homelessness? And these are some of the things they came up with. They're particularly interested in the impacts of policing. What happens when police change their patterns of where they do policing? Do you get movement in the homeless folks? And what's the relationship to services? What happens when you open a new bathroom? That's happened in Fault Line Park. I believe that's the last question down there. How do public bathrooms affect where homeless people sleep? Fault Line Park had a bathroom that opened and closed several times. It definitely did attract homeless to the park, and that's why they closed it. But we don't really know what that looks like from a geographic perspective. They're also looking at how changes in vacant parking lots and whether homeless folks cluster near trolley stops. I did have some slides on the trolley stops one. Really fascinating analysis. I realized that I didn't understand it well enough to really explain it, so I took the slide out. But the gist of it is we've got a guy who is basically doing hypothesis testing with the distributions of homeless folks. It's a Monte Carlo method where you go and distribute. If you propose that homeless folks cluster near trolley stops, you can programmatically create that. You put a Gaussian distribution around the trolley stops, and then you do a hypothesis test. It's based on a nearest neighbor analysis. Really interesting process, but it's things like that we're able to do when we have this really low-level demographic information. One that I didn't mention is we also have from Economic Roundtable this incredible collection of probably 2,500 points of data from surveys. Individual surveys with homeless folks, looking at how long they've been on the streets, what substance abuse problems they might have, sex, age, where they were born, all sorts of stuff like that. I think there's 40 columns. I would love to have some folks who are interested in exploring the issue, doing some basic descriptive analysis on that. If this is sort of stuff is really interesting, again, that's a link to the blog post that has links to everything else, including our main data sets. And again, we'd happy to help if you've got an interest in doing some volunteer analysis on these sorts of things. All right, thank you. We have time for questions. Has there been any specific analysis of Ocean Beach? We haven't done anything particular simply because we don't have good data of the area. There are some, as you saw, there was a lot of points down around Ocean Beach. It seems to me that the homeless at Ocean Beach are a very different character than the ones that are downtown, a different set of issues. And there is survey data, but I think it's mostly conducted downtown, and I don't think they're going up to Ocean Beach. For those sorts of things, I usually just go talk to some of the researchers, because they spend a lot of time talking to homeless folks, and they can give you a basic hunch on stuff, but we don't really have good data to separate those two regions out.
Do you know of any projects from the city of San Diego that they're willing to do an API to release the data to make it more easily accessible, or if they have plans for that?
Well, the city doesn't actually have much data. One of the questions here I actually got from Omar Passan's staff, and they have to work with the other agencies to get data as well. I was actually kind of surprised. I'm always surprised by this. You'd think that there's more data sharing going on behind the scenes than there actually is, but there isn't. So an API would be interesting, but we have to get access to it first, and that's just going to require some footwork. The Regional Task Force for the Homeless has a new executive director that's a little more open with that, but I haven't managed to get all those files out yet. We're looking for a good lawyer to go lean on people for with PRA requests.
Can you go into a little more detail as to what happened when the predictive analysis, the predictive model was created for homelessness in San Diego and the problems? Could you basically went briefly over the they were a little bit too forceful in their prediction. So I'm wondering, can you give us a little more details as to what the conflicts were and how you'd see us getting around that in the future, or people getting around that in the future?
Can you be more specific about which conflicts?
So you made a predictive model that people made a predictive model that was successfully.
Oh, right.
Homelessness. Yeah.
I'm not as well informed on that model as I'd like to be. The conflict was that it required a lot of administrative data that came from the county, which the county did not agree with Economic Roundtable they had rights to use. And so the county said, you got to give this back. And Economic Roundtable was like, yeah, no, this model is awesome and it needs to get out in the world. So that issue, the way that I hope it works is that there's lots of these sorts of conflicts that play out. You see them in the news. Everybody behind the scenes really wants to make this work. Nobody's like, yeah, no, we don't want to solve homelessness. They all really care about it. But there's a lot of other issues that they need to work through. And I'm hoping that the existence of models like that can help people intervene before folks become homeless paves the way for these agencies to release the data and figure out how to share it. It's all privacy encumbered, right? It's stuff like coming out of people who are filing for unemployment. So it's really not easy just to hand that stuff over to another group. You really got to do a lot of footwork before you can make that data flow. Yes?
I think this is less of a data question, rather more of your experience working in the homelessness space. What do you think are the root causes, and what are sort of like the low-hanging fruits that should be tackled to address homelessness?
Yeah, so if we had a really good handle on how to solve it, we would have solved it. It's really complicated. And the root causes depends a little bit on how you phrase it. A lot of it is kind of there's a mindset to it. The one that I hear most frequently lately is that it's a failure of support systems. that in order for a person to become homeless, there's a bunch of stuff that has to go wrong. It's not just that they lost a job. It's not just that they had a health problem. It's a whole bunch of things. There's a path of going down that you go through before you get to the point of being homeless. And so some of the work is going on and trying to fix those things that happened before then. So, but then when somebody does become homeless, it's like quicksand. It drags you down. If you can't afford to live somewhere, you can't afford a shower, you can't afford to go on a job interview. So one of the solutions there is called rapid rehousing. You just get the person into a stable home situation immediately. There's also a change in the last 10 years of called Housing First, which it used to be there was a very moralistic attitude that you had to get clean and sober before you got home. And now they're saying, look, we just give you a home first, then we solve the problem. Part of the issue there is that in San Diego, the top 36 users of services, the ones who call 911 the most, the ones who get hit by cars the most after drinking, they cost the county $40 million a year. It's $1 million a person for the top users. Getting those folks into housing fast is a really valuable thing to do. So that's one of the things that we're trying to look at is what are the economics behind it? That's a little difficult because it intersects with people's individual characteristics. That requires survey data, and that's hard to get. All right. Thank you very much.